Hi, everyone. Welcome back to the first Ontario One stream here at today's first FTC Kickoff. For this next session, please welcome robotics engineer from Studica, James Taylor, for an introduction to block programming for autonomous mode.
Hi guys. So in this session, I'm going to go over basic autonomous in blocks for the control hub. I'm going to share my screen here. So to start off with, we are going to set up our hardware names for our robot. Here I have the basic wiring diagram for a basic bot, which is normally built within the kit of parts of either Rev, GoBuilda, or Bitsco with the Tetrix system. If I can have my mouse over here. So here we have the left motor, the right motor. You also have encoders and different sensors being plugged in. You have the battery that goes into the battery port of the control hub. If you can see closely, this image somewhat resembles the pinouts of the control hub, even though they're not labeled. So the left motor and the left encoder are going into the motor 0 port of the control hub. The right motor and the right encoder are going into the M1 port of the control hub. And then you can also see there is a servo connected. The servo would be going into servo 0 port on the front of the control hub. And then we're also adding the touch and the I2C color sensor into the control hub on the right-hand side. In each FTC kit comes the Rev Control Hub kit. And the kit includes the touch and color sensors, so there's no need to worry about having to buy that extra. Gonna go on. So to first configure the robot names, we're going to switch to the driver station phone. On the driver station phone, we're going to open up the driver station, connect to the robot, and then once we're connected to the robot, we're going to press on the 3 dots on the top right-hand corner. There you'll find configure the robot. That'll then open up a new page where you can create a new configuration. So hit new if you don't have a previous configuration, or edit a configuration that you already have. Once you're started a new or edited a configuration, you can then select on the expansion hub. It'll either be portal 1 or portal 2, depending on which configuration you're doing. By default, the control hub will be at address 2, but it could also be on address 1. This is because you're allowed 1 control hub and 1 expansion hub on your robot. So the addresses could change, and you can set it yourself if you'd like to. Then we're going to click on motors, and in the 0 port, we want to say the type of motor that we have. In this picture example, we have a Rev Robotics 40:1 a HD hex motor. And in port 1, we have the same motor. Now, if you have a Bitsco kit, you might have a Torque Nano motor. And if you have a GoBuilda kit, you might have a Yellowjack. So you just select the appropriate motor based on your kit or whatever motor that you're using. If you're using an AnyMark motor, then you can go with the Nevres. As you can see underneath the motor name, I put left for 0 and then right for 1. This will then correspond to our wiring diagram and for in the code when we need to use it. Then to program the robot, you can go back to the main driver station screen. In there, you can find program and manage, which is on the same 3 dots as we did with configure robot. What program and manage does is it opens up the robot controller info page. In that page, you can see the wireless network's name of your control hub, along with the password for that control hub. You can also see the IP address that your control hub is at. In this case, the IP address will always be 192.168.43.1 colon 8080. You can also see if the control hub's internal server is running correctly. As you can see in the green lettering there, running okay. It's always, if the server is not running, there may be an issue. You might need to update your control hub, or there might be something wrong with your control hub and you need to contact Rev Robotics support. As you can see here, the recommended browser to use for connecting to the control hub is Chrome. In this picture, we are going to the address of 192.168.43.1 colon 8080. Once you've connected to that address, you'll see the screen pop up asking if you want to do blocks, onbot Java, or you just want to manage the control hub device. In this case, as we're doing a blocks tutorial, we're going to select blocks. Now in the blocks page, there might be some code, there might not be code. In our case, we're going to create a new op mode as we want to create a new block section to use for a simple basic autonomous routine. So when we select create new op mode, we're going to give the op mode a name. In this case, we can name it whatever we want, but we're going to name it autonomous mode. Make sure to keep it one word and to have the capital of the first letter. And then as sample, you can choose a sample if you want. You can leave it blank. If you choose a sample, then it will populate code in there for you. And you can skip some steps of grabbing and dropping the blocks for different things. Once you pop into the blocks, by default, it always assumes that you're making a teleop op mode. So what you need to do is right next to, or right at the top of the screen, there will be a teleop dropdown, as you can see in the picture. You're going to switch it to autonomous. By switching it to autonomous, you're now telling the driver station that this code will be in the autonomous section and that the code can only run for 30 seconds. After 30 seconds, the code will stop and it will stop all motors or servos that are running at that time and will prep for when you switch to teleop mode in the competition. It's specific to note that you should try and limit your code to be 30 seconds or less. And most times you want to be maybe a second less so that if anything goes wrong, your robot can still manage some functions. So before you even create an autonomous routine, there are some design aspects that you should take into consideration. Should it be flowcharting, pseudocode, moving your robot yourself and seeing what it needs to do and writing it down. In this case, I'm going to choose pseudocode. Pseudocode is easy, almost English code that is not exactly code, but breaks down where the code should be and what needs to be done. In this case, we want to drive forward 1 foot and stop. So the pseudocode will be, first off, I need to repeat until the stop button is pressed, which is default by the driver station code. My second step would be to set the left motor to power 1, which means 100% forward. And then I also want to set the right motor power to 1, which is 100% forward. This will drive the robot 100% in the forward direction. Now, as we're doing a simple autonomous routine, we're going to use a time delay, and we're going to wait 1 second. After that 1 second has elapsed, we are going to set the motor power for both left and right to 0. That will stop the motors. And with this, we can drive the robot forward for 1 second, stop, and that's our autonomous routine. Very, very simple. So exploring the DC motor tools in the blocks programming environment, you'll need to start the program by setting the direction of the right motor to reverse. Now, in this example, we're setting the right motor to reverse, but on your robot, it might be the opposite. You might need to set the left motor to reverse in order to drive forward. The reason we set one of the sides to reverse is that the design of the motor, if I was to grab a motor here to show you guys. So the design of the motor is it will spin clockwise in one direction. So if the motor is placed here on the chassis and it's spinning clockwise, like this, and going in, it'll spin in the reverse direction. However, if the motor was here and it spins clockwise, it's going to spin in the forward direction. So if I'm on the right side of my chassis, I need to reverse the direction of this motor in order for the robot to drive forward. So blocks code is super simple that you can just drag the block that you want to drop in and drop it and click it right into the place that you want it. So if you notice that the repeat loop can be adjusted from while until, it's just little things that you can do. A do while will repeat, and then an until will do different configuration of looping. You can decide which one works for you better. Just test. So we want to repeat until the autonomous stop is requested. So the stop is requested can either be done by the driver station automatically or by you hitting the stop on the driver station. So we add the call autonomous is stop requested to the repeat until. So therefore, in that loop, it will keep on looping and looping and looping and looping until that autonomous stop is requested by the driver station. Now, in the dual motor section, you can find the actuators such as DC motors. If you want to set the power, if you want to set the mode, if you're using encoders, you want to use the target position, you want to do a zero power behavior, it's all in there. Now, generally, we won't set the power to 100%, as it's never good to have the motors spinning at 100% speed. So you want to sometimes bring it down a little bit. In this case, if we set the motor power to 0.5, we're actually spinning at 50% duty cycle. So the robot's only moving forward at half the speed of its full potential. Now, if you refer back to our pseudocode that we needed a wait function in order for the robot to drive forward and not just stop instantly, we're going to select linear op mode at the very top of the blocks. In there, we can find the sleep command. Now, the sleep command should only be used in autonomous and not in teleop. The reason why is sleep will actually halt the processor on the control hub, and therefore no other code can run during that period, which is bad during teleop as it won't be updating for when you're driving with the remote control. However, in autonomous, it's completely fine as there will be no remote control during autonomous. Now, if you look here, we have the full block diagram of our pseudocode. We have the call autonomous wait for start. So that will wait for the autonomous period to start. We then reverse the direction of the right motor so that the robot drives in the forward direction. And we're going to repeat until autonomous one is stop requested. So either you push the button or the system tells the robot to stop. Now in that loop, we are setting the power of both motors to 50% to prevent the motor from just gunning it and the robot driving wherever it wants to drive. And we're going to wait, in this case, 1,000 milliseconds, which is equal to 1 second. And after that 1 second is complete, we're going to stop the robot by sending a speed of 0. We'll also wait an extra second just for prosperity, and we will end the loop. There are other things that you can use in autonomous, such as encoders. Encoders will give us the exact count of revolutions that our wheel has spun or our motor has spun. This is good for if you're doing distance moving or you're doing certain path planning, as doing a time-based code like we just saw previously is not the most efficient way to program. Using sensors and different algorithms is the best way to do it autonomous. Now, for a beginner, we try to stay away from that. As the moment you start adding sensors and control loops, it starts to become very complicated for someone that does not know programming. In this case, you can use encoders and you can figure them out and learn how they work and everything. In FTC, most motors come with the encoder already attached to the back of the shaft of the motor. As you can see in this motor, here you have the output shaft where you put your wheel, your gear, or your sprocket to control whatever you're using. And on the back here, this blue part, we have the encoder. And the encoder wire will follow the motor wires to the control hub and plug directly. If I switch to the control hub view, we can see the motor 0 port here. And then we can also see the encoder port right next to it as they're connected together. This way in the code, we know that if there's an encoder plugged in here, it's resulting with the output on motor 0. If I plugged an encoder into 1, but the motor is in 0, your internal algorithms won't work that well. So always make sure to plug the encoder into the correct port.
Hi, James. Sorry, your window was still sharing and we couldn't see it. So would you be able to stop sharing and show us that again, please?
Already this one?
Yeah, if you can stop sharing your PowerPoint and we'll
Oh,
see your
yeah.
camera then onto the other one. Thank you. There you go. Thank you.
Yeah. So I'll say that again. So here we have the motor port 0, and then next to it is the encoder port, if I can get closer.
That's
So
good.
if you
Thank
see
you.
here, you have the 4 motors. Now, if you plug it into the encoder into the 1 port, which is here, but the motor is in 0 port, it won't work correctly, as the internal algorithms require it to be in the same port in order for it to work. Share this again. So in this case, we've added the motors to right after where we set the right motor direction to reverse. And in this case, we're telling it to run the motors without an encoder. What this means is normally in an autonomous mode, the control hub assumes that you have an encoder plugged in for the motor and it will try to run with the encoder. However, we're not using an encoder, so we're going to run without the encoder. Now, if you wanted to use the encoder, you just click on it and change to run using encoder. So what will happen now is that the encoder counters on the control hub will start counting how many revolutions and counts your motor has done during the period that it's being used for. We can then change the run mode to run to position. What this does is that you can then choose a target position that you want to run the motors to. If we take the Pittsco Torquenados, for example, the encoders have a count revolution of 1,440. So every one rotation of the output shaft of the motor will result in 1,440 counts. So if we wanted to move forward uh, one rotation of the wheel, we would then set our position to 1,440. As you can see in the repeat until, there is a set target position. In this case, the left and right are set to 4,880, which means we want the motors to move forward until the count reaches 4,880. At that point, the internal PID will stop and the motors will be done. So I'm going to boot up a control hub here so that I can show you guys some of the code itself with demonstrations. Just going to connect to the robot. So I'm now sharing the screen with the connected to the control hub. As you can see, I'm at 192.168.43.1. Here we have our connection info. We can click on blocks. We can go on bot Java. We can manage the control hub if we want to. However, I'm going to click on blocks. As you can see, there are no op modes currently. So I'm going to create a new op mode and name it my auto example in this case. Do we want to go with the basic, as you can see here, here's the samples. I think it's always a good idea to use a sample at the beginning and then you can always remove and delete the blocks after. Okay. And you see the blocks that are created. What's nice is in the blocks code, it also shares the Java code so you can see how it's done. And when you're done, if you want to switch to onbot Java, you can just copy and paste this and use it in your onbot Java when you want to switch to a text-based form. So in this case, I first need to switch to autonomous as I'm right now in teleop. So I've now switched to autonomous. As you can see here, it's now changed to autonomous. If I switch back to teleop, it's in teleop. So we see here, we have our little boot up sequence. We're going to wait for the start button. And then when it's active, it will start running. Now we want to change a few things right away. So we're going to switch this to until. Oops. I'm just trying to navigate back to stuff. So if I click on linear op mode, you can see the different calls here. I'm going to drag my call in. As you notice, I don't need to attach it right away to a block. I'm just going to replace this one. Now, delete that. So now I'm going to repeat until the stop is requested. Right now, my code is not doing anything as there's nothing in here except the telemetry update. So now I want to go to actuators. Yeah, there's no configuration set yet for this control hub that we have here. I'm just going to quickly hop in and create one so that we can. Okay, there's now a configuration set for the robot. So I should now be able to, I'm just gonna save this op mode. I'm gonna go back in, so hopefully it updates. As you can see now that I have a configuration set up on the control hub, that my actuators are now showing that I can use. So I'm going to go to DC motor and I'm going to drag in the set motor direction in reverse. It's actually got to go. This has to go after call. Wait for start. And I'm going to set the right motor to direction reverse. So what's nice in blocks is that if you have your configuration set up, whatever you name your device will be here. You don't need to go and figure out what it is as you do with the text with onbot Java or with Android Studio. You can find it right away right here with the blocks code. Once that's done, I can see I have ready to go, but my motors still won't move as I'm not telling the motors what to do. So what we're going to do is go to DC motor, dual, and I'm going to, as you can see, I have my left and right already set. If I had more motors and stuff in there, I could easily just go in and change it. So I'm going to put set power left to 1 and 1. However, I don't want it to be 1 and 1. And I also want this constant to be filled so it looks better. So I'm going to the math tab and I'm just grabbing a simple constant over to here. Now I'm going to add 0.5 and 0. So if I were to leave it now and run it as is, the motors would just drive forward at 50% speed forever. There's no stopping here. We always want to add the stop. But before we add the stop, we need to add the little timer that we talked about in our pseudo code. I'm going to go linear op mode. Now, if you see here, we have call auto example.sleep millisecond. I'm going to drag that in, put it below the set power. Now, by default, it's already at 1000, which is 1 second. However, I'm still going to add the constant, so I'm going to drag this over, put that in there. I'm going to add 1000. By adding the constant, I know that I'm not using the default, even though it still is 1000, but it allows me to edit the code a lot easier. And now our motors will drive forward for a second, but there's nothing afterwards to tell it to stop. So I'm now going to go back to dual, drag this in. I'm going to drag some constants in again. And there you go. We have a simple autonomous program here. So now what's going to happen here if we were to run this code is that there are 30 seconds in the autonomous period. So every second, something's going to happen. Now, when you loop through here, my speed's going to be 50 for 1 second, and then it's going to go to 0. But because there's no delay here, what it's going to do is instantly loop back like this to here and go back to 0.5. So it's only the motors are only going to be stopped for a small, minuscule period of time that you won't even see it. So the motors are still going to drive forward for 30 seconds. To overcome that, we're going to add another autonomous sleep mode. Add the constant. Make it 1 second. So now what will happen is the motors will drive forward at 50% for 1 second, then stop for 1 second. And then it will go into the loop and loop back around and start this code again as the stop has not been requested yet. Now, if you do the math, there are 2 seconds here in a 30-second time period. So that means it's going to repeat this loop 15 times. So essentially, your robot will drive forward, stop, drive forward, stop, drive forward, stop, drive forward, stop. Now, some people want that, some people don't want that. So if I only wanted to drive forward for a second and then stop, you could be really cheeky and do this. So 29,000. And you're done. Now, there's other ways to break out, but this is just the simplest way to do it. By doing this, my robot will now drive forward for a second and then stop for the rest of the autonomous period, which is what you want to do. In this competition for this year, when you just need to drive to the white line to score points in autonomous, this could be a simple code that you can run for your autonomous, and you just need to change the timing periods for your robot based on its speed and the motors that it go. Then let's just show the encoder example over here, and we have time. So this is just a simple, I'm going to move this to the side here so that we can have the side-by-side comparison. So now we want to go into sensors. So if I go into motors, you can see here the set mode. I'm going to drag that underneath the right. And I want it to run using encoders. I'm going to do that for both. I'm going to set target position. Now my target position, I'm always at the constant. In this case, I set that I'm using a Pittsco motor, which is, if you remember, a 1,440 count. I want to do 2 rotations of the wheel, for example. So I'm going to do 2,880 and 2,880. So based on this, my wheel should rotate twice and then stop. I then want the motors to spin at 50% speed, not 100. So I'm going to drag the constants in. Once that's there, I'm then going to sorry, I'm stuck here for a second. There we go. Oh, I forgot to add the run to position. So we also need to add another mode in here, and then add it the wrong way around. So first we want to reset the encoders at the beginning when you start, and then set it to run to position. Run to position will sets the mode of the motors to use the internal PID of the system based on your encoder count and everything. The robot configuration that you set on the driver station phone will configure it to use the correct count for the encoder built on the back of the motor. So if I were to use this code right now, it would drive forward to 2,880 and stop there. Now, I don't need to add any more code, as what happens is if I loop here, it's going to keep looping until it hits this 2,880. When it hits this 2,880, the motors won't move anymore. It'll just go to 0. So I don't need to add a sleep counter in here anymore, as they'll just keep looping and looping and looping and looping, but the motors won't change as they've already hit their position. Now, if you notice, the code itself inside the loop, which would have been this, is much smaller. All we have to do is just add a little bit more at the beginning and the initialization stage. So what's nice is that this code is more ideal in what you want to run in an actual autonomous. However, this code is nice to start with and get your robot moving. So I would recommend to always start with a little bit of a time code to just see that your robot can function, and then switch over to the sensors as we are here, where you can use the encoders to go exactly to the position that you want to go. What's nice with this is that it will do the same thing over and over and over and over again, and you won't need to recalibrate it that much. However, with the time-based code, depending on your battery voltage, you could drive farther one day, drive less one day, you can be right on the money, or your robot might turn and go a different direction. So it's always good to use the sensor data, as the sensors will put you right where you want to be. And it's a little bit of cleaner code, and it moves you on to how autonomous should be programmed, especially in the real world. I'm just going to remove this code. And now what we can do is we can save this off mode, and we can see save completed successfully. If I switch over to my other camera, I'm going to stop sharing to show you the camera. On the driver station window, the autonomous is on the left-hand side here. If I were to push it, you can see that I can't really, but it's there. So we can see the auto example, and then we see the timer there for the 30 seconds of autonomous. If I hit init, it will initialize, and then of course I can hit play and it will run the roll. Now, of course, it tossed an error because the control hub is not actually connected to a motor or an encoder. So the robot instantly stopped because it did not detect anything. So with this code, we can drive the robot to where we want to, and you have an autonomous that can complete the challenge.